guys, welcome back to 3.2.3 checkup. What this checkup is going to go over is a little bit more about some domain and range topics. So our first questions deal with this table shown here. So in this table, we see that it's dealing with the cost for a rental truck, which we're going to represent with C of X. Depends on the number of days the truck is rented, X. Okay? So cost, how much money you spend, depends on your number of days. That makes sense. We see at 1 day it's $25, 2 days $45, 3 days will cost you $60, and 4 days will cost you $70. The first thing it wants to know is, what does it mean that C of 3 equals 60? Well, remember, our C stands for cost. So the cost, and our X in here is our days. So the cost at how many days? 3 days is how much money? $60 or $60. So don't overthink these, like if they want you to write it in a sentence or what does this function mean? What's first? Cost is first. What's on the inside? Well, that's days. How many days? 3. And then how much the final product is. The next question is this table representing a function? Remember, a function should have only one output for each domain, where domain is our input, if we remember. So I see 1 going only to 25, 2 going only to 45, 3 only to 60, and 4 only to 70. So is this a function? Yes. Only one output for each input. That means it is a function. What is the domain? The domain is what you put in. So the domain is what we're putting in, or how many days have passed. So it's everything on that side. So it's 1, 2, 3, and 4. The range of this function is what we get out of it. It's that output side. It's the amount of money we have. So it's everything on that output. 25, 45, 60, and 70. And number 5 wants us to list our ordered pairs. When you're listing ordered pairs, what that means is what you would kind of graph. So if you remember the parentheses, your domain is first, so that's the 1, and then your range will be the second thing. So 1, 25. Your next order pair, 2, 45. Your next order pair, 3, 60, and 4, 70. So your ordered pairs are just rewriting those tables as little groupings. Okay? So just another way to represent a function. And hopefully you kind of remember that. We will get into graphing. You'll be seeing ordered pairs a lot. If you have questions of that, make sure you're letting me know or see me during office hours. So number 6, we're now moving away from that table. We have some new numbers. It asks, does the list here represent an ordered pair? A function. So do we have a function? Yes or no? And that's again looking for one output for each input. Alright, so first thing I got is 4. Cool. It goes to 10. We're good right now. 3 is not 4. Still good. 1, I got 3, 4, and 1, all different so far. 2, still different. We really care about the domain here, and domain is always our first number. And my last one also has 4. So what's happening here? Well, my domain 4 here is going to 10, and my domain here 4 is going to 25. Which means if I were to write this out as like a table, I would have 1 to 5, 2 to 25, 3 to 15, and 4 going 2 different places, to 10 and to 25. When you have 4 going 2 places, this is not a function. 4 goes 2 places. Functions should have a 1-to-1 correlation between domain and range. Okay? And this is a great way to kind of test these problems if you want to make the table. So we'll do that for the next one. I see 0 to 5. That's great. 0 goes to 5. 1 to 3. Still good. 4 to 2. And 5 to 5. At no point did I repeat any of these domains that I put in. So yes, this is a function. Domains go to one place. So that's what you're looking for with your domains. Is it a function? That depends. Is it only going to one place? And the next problems are graph problems. And to determine whether or not a graph is a function, we do what's called the vertical line test. Okay? So the vertical line test means if I were to draw a vertical line, okay, just like that, and I were to, oh no, come on, or it's not going to do what I want. And let me grab something. Never mind. So if I were to draw a vertical line anywhere on my graph, does it hit 2 outputs? So I draw this line here. It only hit my line once. I draw a line here. It only hit my line once. Draw a line here. It only hit my line once. And I can do it on the other side as well. No matter where I draw a straight up and down line, it's only hitting my line once. If that happens, yes, it's a function by the vertical line test. So the vertical line test is super easy. You literally just draw a straight up and down line and ask yourself, do I hit my line? Do I hit my graph twice? Okay? And so let's look at the next one. And hopefully you'll start to get a better idea. This next one, I see this V shape. In this V shape, I can draw a vertical line. I could draw it over here. It only hit that V at that one point. If I drew a different vertical line, it still only hits my V at one point. So yes, this is a function by the vertical line test. Which some of you might be asking, then what isn't a function? You know, what would it look like if it failed the vertical line test? When I do this next one, what you'll see is if I drew a vertical line, my line has hit it at 2 points. When I have that 2 point or 3 point, or if it hit it at 20 points, it fails the vertical line test. So no, this is not a function because of the vertical line test. And what that means is if I drew a line straight up and down, it failed. And you could do this. If we just had like a nice linear graph like this, if I draw a vertical line, it only hits at one place. If I have a graph that maybe looks something like this, an S shape, well look, my vertical line is hit at 3 different places, so it's definitely failed. So if you have it hitting at multiple different places, it fails the vertical line test and is not a function. Yeah. If you have any questions, please feel free to reach out to me.